What's going on, YouTube? Boosted Bikes here, aka Mr. Turbo, aka Justin. And here we're going to go over my 2024 Gasgas SM700 Turbo. So let's get into it. Started out by buying a brand new 2024 Gasgas SM700, and immediately I strapped a turbocharger on it. So here we have the Garrett GBC 17-250 turbocharger. It's kind of a mouthful, but that's their small streamlined series of turbochargers. This one's good for up to 250 horsepower, but it's sized for this engine. It's sized from anywhere from like a 700cc to a 1000cc motorcycle. And here we have a custom 3-inch dump coming off of it, side exit. We have our Turbo Smart Comp Gate 40 up here. That's controlling the boost on it. It's gotten pretty toasty. I've never seen one of these discolored except for this bike, but it still works flawlessly. They make good products. Now, I set out to make something that has factory riding characteristics with a lot more power. So we took the stock bike, threw it on the dyno, and we got 55 horsepower to the rear tire, just bone stock. With full bolt-ons, we have a Gasgas SM700, and that made 72 horsepower to the rear tire. With this setup, the most I made was over 95 horsepower to the rear tire, and that's the current tune configuration I have in it now. So it's quite a bit more than they ever came with stock, and it's more than you could ever do with any bolt-ons or big bore kits or anything like that. So I guess let's get back into it. So from this side of the bike, you can see I have the ram air filter. This is how I'm feeding oil to the turbo. So I tapped into the oil filter housing, welded a little 3AN line, and I also put a restrictor in here because it was getting too much oil and the turbo was actually smoking. So I restricted it. I didn't go too small in the restriction, otherwise I'd end up blowing up the turbocharger. So I have about a 0.7 millimeter restrictor in it right now. It could actually be 0.8 millimeter, and that's pretty small for a ball bearing or a journal bearing turbocharger. Normally with like a ball bearing turbocharger, you run a 1 millimeter restrictor, or maybe a touch smaller. The ball bearing turbos don't need a lot of oil pressure. They only need basically oil flow to keep the bearings lubricated and also for cooling. But the journal bearing, the oil is the bearing essentially, so you do need more oil going to it. But even with this setup, the turbo works flawlessly. It's just enough oil to keep the turbo always perfectly cool and also lubricated, but at the same time it's not smoking, and it's not oil starving. It's perfect, really. So getting back into the build, enough of the nonsense. Let's check out this intake manifold. So down here we have our boost pipe running off of the turbocharger, 2.5 inch into here, which then comes and kicks around into the plenum. I made this plenum to mimic the stock airbox, so it has the same volume as the stock airbox and the same bends and characteristics. So this bike rides like a factory bike would. And the reason I also did that is people online will say you can't turbocharge a single cylinder motorcycle. And why is that? Well, it's really because that single cylinder is pulsing, and it's hard to spool a turbocharger when it's getting pulses of air. When you have multi-cylinders, that pulsing is less of a thing because it's evened out with other cylinders. The pulses are so fast, it ends up being like a constant stream of air, and that's the concern with turbocharging. More on the intake side is that the intake air is getting pulsed in, it's never actually building up boost. So with this setup, I mimic the stock airbox, so it has stock riding characteristics, but also this is like a boost box where air gets accumulated in here, and it basically has, it's a space for air to build up pressure. If you didn't have this, it would be very hard to build up pressure, and it would be hard to keep boost as well, because the minute your intake would open, it would just use all the air in the intake track, and you would never end up with like any pressure. It would never build boost. So here, this is the most trick part of the setup, I would say, is this intake manifold. There's a lot. This is over 2 inches thick and 3 inches on this side. It tapers down, also fits in the stock frame rails. I have a Turbo Smart V-port blow-off valve right here. I'm tuning this through a Power Commander 5 that I have in here. Actually, a Power Commander 6, I lied. With a Power Commander 6, you have to be a dealer. I'm a DynoJet dealer, so I can fully unlock that ECU, get 250% fuel tables, and up to 5 degrees of ignition timing. I think it's actually unlimited once you're a dealer. But normally, you'd only be able to modify a Power Commander 6 to 15% fuel and 2 or 3 degrees of timing. which obviously wouldn't have been enough. At full boost, I'm using about 40% added fuel, so at 10 pounds of boost. So obviously it wouldn't have worked if I only had 15%, or I'd be limited to how much boost I can run based on how much fuel I can run through the engine too. If you weren't a dealer, you could probably run 2 or 3 pounds of boost through this setup, but because I have the capability and this is a off-road vehicle, I could go ahead and get away with it. But back to the setup, the real magic is this map sensor I have wired into the power commander. Now, for every pound of boost, this is adding roughly 5 to 6% of fuel. And that's really the magic behind this, because at different loads and different gear, you're going to build boost in different ways. You're not going to build the same 10 pounds of boost at the same RPM in every gear. Each gear is a different load, which is going to spool the turbocharger differently. So with the map sensor though, it's detecting how much boost the engine's seeing and adding fuel accordingly. So this really is like a factory bike. When you rev it up, you can hit the limiter. It's not going to dump a bunch of fuel and blow a bunch of black smoke because it's not seeing any boost. So it's not going to be dumping fuel down. Got some heat in it now.